Guys, let's solve question number second of bi-weekly contest 181, and it is compare sum of Bitonic parts. Okay, this is a medium problem. What does it say is you're given a Bitonic array of nums of length n. Split the array into two parts. Ascending part from 0 to peak element inclusive, and descending part is from the peak element to index n minus 1 inclusive. Peak element belongs to both the part. Return 0 if sum of the ascending part is greater, 1 if sum of descending part is greater, minus 1 if both sum are equal. Note, Bitonic array is an array that is strictly increasing up to single peak element and then strictly decreasing. Okay, this is what the Bitonic array is. An array is said to be strictly increasing if each element is strictly greater than its previous one if exist. If array is said to be strictly decreasing if each element is strictly smaller than its previous one if exist. Okay, so these are some definitions. So I mean what this, if you see the constraints, what is nums dot length can be up to 10 to the power 5, and nums of I is also 10 to the power 9, and nums is this nums is a Bitonic array for sure. And Bitonic array is, so it is something that it will be strictly increasing up to the peak, so it will strictly increase up to the peak. So here is the peak, and after peak it will be strictly decreasing. Okay, so this is how the Bitonic array is. Now let's discuss the example. So if you see this example, nums 1 3 2. Okay, so 1 then 3, this is strictly increasing, then there is 2, so 2 is decreasing, and then 1, so from 3 here it is strictly decreasing. So here 2 3 is the peak element. Now what does this we have to split that into two parts. Okay, one is ascending and descending part. So here what is the ascending part? So this is the ascending part from 0 till peak, and descending is from peak till this n minus 1. Okay, so what is the sum? This is the ascending part, this is the descending part. What is the sum over here? 1 plus 4 is 4, sorry, 1 plus 3 is 4, and here the 3 plus 2 plus 1, that is equal to 6. Here if you see, this is ascending and this is descending. So here descending is greater than ascending in this example. So what it has said, that if sum of descending part is greater, then return 1. Ascending is greater, return 0. If both are equal, return minus 1. So this is the simple approach that is given to us, and it is said that nums is a Bitonic array in the constraint. And also if you see nums dot size, right, so it is minimum 3. So minimum minimum the size of the array is 3. Okay, so let's now solve this problem. So this array will be either like this, 3 size like this, or like this, or like this. Okay, so this is the only possibility. And since in the increasing and decreasing part, both this peak is included, right? So if in this example we see there is no decreasing part other than the peak. Okay, peak. In increasing part, it will contain everything. In decreasing part, just the peak. In this example, in increasing part, it will be just peak. In decreasing part, it will be the the remaining part. Okay, and here it is both, till here is increasing and till it is decreasing. So what we need to do is we need to simply iterate in this nums. We will simply iterating. So nums is 1 3 2 1. We will simply iterate, start iterating and see if this is an increasing part or not. Okay, and since it is bitonic, means it will increase and then decrease. Okay, so from what we can do is we can compare each element one by one if it is greater or not. Okay, so if nums of I is is you know greater than nums of I minus 1, which means this is increasing, right? Otherwise it would be decreasing. Okay, otherwise it will be decreasing. So what we need to do is we need to sum up till increasing, and after that we have to sum up till the decreasing. So what we can do is, in this case, we will start iterating from here. Okay, so this is what my I, and I will go till last. Okay, I will compare if it is increasing. In this case, yes, it is increasing. So I will have my increasing variable as nums of 0. Okay, this is the first variable I will take in my array. Now, since our array length is minimum 3, so we don't need to worry about this edge case. Okay, if there is no empty array or any such things, it is of length 3, so we didn't need to worry. Increasing is nums of 0. Now we started from this I. Here we see 1 is smaller than 3. Okay, which means this is increasing. So we will add the value. So increasing was initially what? 1. Now since it is increasing, we will add 3. Now I we move to 2. Now we compare 3 and 2. We find this is not increasing. Okay. So what we can do is we can break from here. Okay. So 1 plus 3 is, sorry, here 4. Yeah. Now we can break from here. What is our I? Our I is at index 0, 1, 2 and 3. I is at 2. Okay. Now what we can do? We need the remaining sum, right? Remaining sum along with peak as well. So if we have this decreasing array, what we can do is we can add nums of, I minus 1, which will be the peak, and then we can start from I till n minus 1. So here it was, from 0 till increasing we were doing, and increasing was based on check. From here remaining, if once we have found the peak, so remaining is definitely decreasing, so we can go from I till n minus 1 and we can add the values to our answer. This decreasing nums of I, and now at the end we will have this value for increasing and decreasing, and we can simply compare on these three things, okay, which is greater, which is not, and then we can return accordingly, values accordingly. Okay, so this is the simple straightforward thing. If you see in this case, if we calculate decreasing, so it was nums of I minus 1, that is decreasing will be initially 3, because it is I is had 2, okay, index 2, and I minus 1 is here index 1 and value is 3. Now I can just keep on adding, my loop it's going right, we can keep on adding. So I'll add 2, so it will be 5, add 1, so it will be 6. And if we compare, so 6 is descending is greater than 4, that is increasing. So in this case we return 1. Okay, now let's quickly code this out. So we have this variable int I that start from index 1, because we are starting the comparison from index 1. Then also one more thing is, if you see this nums of I is up to 10 to the power 9, so we need to take long variable. Okay, in normal integer range it will go out, so we need to take long increasing sum, or I can write it simply as increasing only, which is increasing sum as nums of 0. Okay, now I can loop while, because from 0 I need to go till increasing condition. So while nums of I minus 1 is less than nums of I, which means this is increasing, I need to add my value in increasing sum nums of I. I will keep on adding and I will keep on increasing this I. Okay. Now it would have braked at the point where I would have reached the peak, which means this increasing condition won't be following. So I can have another variable long descending is equal to nums of I minus 1. This is basically adding peak over here. And what I can do is now in the remaining part I need to traverse. Okay, my I is at the peak, so I have added the peak element. I mean, yeah, and now I need to go till last value, and I can keep on adding nums into my descending sum, nums of I, and I can keep on increasing this value. And at the end, this is my ascending and descending value are now created. Now if increasing value is greater than decreasing value, then I return, what are we returning? 0, 1, minus 1. Yeah, return 0. Else if descending is greater than increasing sum, return 1. Need to at the end at the last return minus 1, which means both are equal. So yeah, this is the code about it. If we see the time complexity, so this is somewhere, if we have this kind of array, all increasing or all decreasing, so at max any of these loop, either this one or this one, this one can go at max till O of n. Okay, so our time complexity is O of n, and space complexity, if we see, we are not taking anything additionally other than few variables, so it is O of 1. Yeah, so that is space and time complexity of this approach. I hope you liked this video. Thank you for watching.